Hi there, in this video series we're going to take a look at what you can do with the API that's now included with Gridlock 0.3.9 standard and full. This gives you basically complete control over Gridlock for your own purposes, allowing you to customize it further than what's available in the config control, and this will grow over time, add in more functionality. The nice thing about using the API is that you're abstracted from the actual hardware, so anything you're controlling via the API will work on any controllers that are currently supported via Gridlock. In this first video, we're going to look at using the API to update the grids themselves. In other videos, we'll look at issuing controls and actually controlling Gridlock logic from the API. But for now, we're just going to look at how we take control of the grid and do some drawing on it for our own purposes. There's a number of examples included in the download, so I'm just going to quickly go through a few of those and show you what's possible. I'm going to be demonstrating this on push, but exactly the same behavior will be seen on the other controllers. As you can see, the examples do have some documentation with them, so hopefully that's enough to get you started, and they do build up in complexity as we go through. So this first patch demonstrates the concept of local updates or not. Now, normally Gridlock is responsible for drawing all of the updates to the grid for us when we press buttons, when it receives notifications, etc. But it is possible for us to turn that off and take responsibility for drawing it ourselves. So I'm just going to turn it back on at the moment, and I'm going to press some keys, and as you can see, that's updating for us as we would expect. Now, if I set this to grid local 0, which is what happens when we do the load bang, then even though you can see that the updates are still happening in the status bar, Gridlock is no longer drawing the updates for us. So we can still use all of the core functionality, it's just that we get to draw our own updates now however we want. In this case, I'm just simply going to enable this checkbox, which is going to take some of the output from Gridlock. So we use this helper object here, which is included in the download package, to receive output from Gridlock, and then we're going to do something with it here, and essentially we're going to turn it into a cell command to draw the cell anyway. So if I now turn this on, then I'm getting the updates that are required, but it's actually me that's doing the drawing now, not Gridlock itself. We could go and add a print statement here, for instance, and if we bring up the max window, then when I hit the keys now, you can see that we're issuing this command, sending it into Gridlock via this other helper here, which allows us to send commands in, and we're doing the drawing. So before we move on, let's just take a bit of a more detailed look at this helper. You can see that we've got a number of outlets here, which pretty much all of the Gridlock output or processing that you'll be interested in will come out of. So in this case, we're taking the application output, which is described in the programmer's guide, and processing that information to turn our cell on. You can see the content that's sent out if we open up the monitor screen and say this is the app output. Most of these correspond to one of the outlets on the GLC output object. So if we turn on app here and then we press a key, we can see that we get information sent out as to which grid cell we've pressed and what the current state is, etc. As I say, that's described in the documentation, but you can see here now that turning that on and off emits a series of messages which we can then process and turn into a command here. So you can see that these flash when we're outputting on a particular channel, and if indeed we turn the whole lot on, then you can see that we get various information sent to the HUD to draw the HUD if we've got it open. These commands go to the raw device. So this matrix command here is going to be turned into a MIDI message to go to the device. Then we've got this information going to the display, which is telling us to draw an update here. We've got the application output and then a raw message here of we actually hit that one with a velocity of 109 and then 0 when we turned off. So you get a lot of information here, including, as you can see, if we've got MIDI data associated with the cells, if you've configured that, then we get the MIDI output. We've also got monome information for the monome emulator. If we're controlling rotaries, then we get information out of here. This is general gridlock state. So if we change the state, like the selected controller or something like that, we'll get messages out of here. As I say, this is going to the heads-up display and the mini display inside here to draw those. This isn't used currently, but this will contain all of the information coming from live. And here we have a touch strip outlet as well. So the final thing over here is the instance. At the moment, I'm monitoring all of the instances, even though I'm only using instance 1, but we can select which instance to monitor the input from, or all, as in this case. Let's look at another example. Okay, so this example is pretty similar to the first one. We're building on what we've done there. We're taking control of the grid drawing as well. We're processing the app output, which contains the location of the cell that we've just pressed. But in this case, what we're doing is, as well as sending a grid cell command, we're going to send a on-call command as well, which is just going to randomly change the color of the cell. So if I press now, you can see that it's doing exactly the same thing, except instead of using the defined colors in the config as we normally do, I'm just generating a random color to set the on color for the cell when I press it. Now in this patch we are executing a couple of commands, so we're using the bulking functionality of this patcher here, which we'll look at in more detail in the next patch, but it is important to use the provided abstractions as they allow Gridlock to optimize the incoming updates and perform the physical update to the controller as fast as possible. So let's move on to the next example. So this patch here is just going to draw a crosshair when we press a cell of a different color depending on where the cell is. So I'm just going to press here and you can see we get a red crosshair and turn it off, and the cell is still drawn as normal, so I can bounce around, and we're just using the Y position to determine the color. As you can see though, the drawing of the crosshair doesn't actually affect any of the content underneath, so all of that is maintained for you. So if I press here, you can see even though we've drawn the crosshair there, when I take my finger off, then the contents are restored to normal. So we have a choice when we're drawing the grid whether we want the change to be permanent or not, so that we can do kind of little animation things like this without actually affecting the real content of the grid, and we'll look at that in a few more examples. So I'm just going to quickly go into why it's important to use the abstractions here. So I'm going to bring up the Max window again, and this time I'm going to just check the input toggle at the end, and then I'm going to press and hold so you can see what's going on. So I'm just going to press and hold that. So you see we get the normal 0 matrix 3-3, that's part of the system sending that. And then you can see the two commands that we're sending in, which correspond to the items here, which is just basically telling us to draw a row and a column, 255, which is a bitmap, so that's 8 bits on, and the color at these locations. So we send 2 commands to draw the crosshair on, and if I release now, we send another 2 commands to turn it off. And in the case of this particular command here, we can send it a -1 value to tell it to put it back to whatever it was. This is how we get the ability to draw stuff over the top without actually affecting the contents underneath. So that's what we get if using the normal inputs into this thing. Now what I'm going to do here is turn this checkbox on, which is going to turn on the bulking facility here, and this is what is on by default, so you don't have to worry about this, but on some occasions you might want to send single commands. But if we turn this on now, and then I'm going to hit a location here, so you can see here we've still sent the matrix command, but here we've sent the same commands as earlier, but we've sent it in a single command, and there's some additional messages going on around the side of it. And if I release again, so both of those updates were sent at the same point to Gridlock, and it'll have been able to do some optimizations there. So not particularly important in this case, but when we look at some of the stuff later, then it's important to use this, as we can optimize out a lot of duplicate updates that might otherwise happen in a refresh period. Okay, so now some more practical examples. I'm just going to do some of those, and this one is just to turn this on. Then we just get a quarter beat metronome going across the top. As you can see, it's just again using the draw methods to set the color and then refresh the color underneath, so that we're not actually overwriting the contents of the grid. And now if we wanted to have a metronome or a quarter beat monitor on our grid, it's as simple as that. I'm running Gridlock, I can just open this patch, turn it on and off when I want this indicator running across the top of my grid. The next example we have is something that will allow us to identify which bank we're on if we want to. So see that when I change bank here, we just get a 1, a 2, a 3 or a 4 on the grid. That flashes up for 500 milliseconds, so just a quick half a second. Example A, so this is just a bit more fun stuff. This one just kind of operates a screensaver. So after 2 seconds of inactivity, this one just clears the screen and runs this little pattern. As soon as we click anything, we get back to the normal functionality. If we go on to the second bank, then it's a different screensaver. So you can see here that as well as processing the raw output, I process the raw output here because I don't really care about anything that's been processed by the application. I just want to know when a key has been pressed and released. So I can start off the timer here. So you can see here that we're also taking the state output. So I'm going to go and turn state on here and bring up the max window so you can see an example. And if we look, if I change back to the first one now, you can see that we've got 0 bank 0. The first number here is the controller instance, so we're on controller 1 here, so it's always 0 because it's 0 counted. And then we've just got a simple message here that we've changed the bank. So I'm finding out which bank that we've come from here, sending the metro through the appropriate gate to run the particular little animation that I've got. So if I go on to 3 and just kind of put some stuff there, this one's just random bits in random colors. And if we go to 4, I think this is some kind of wipe. So draws, yeah, just wiping a random color, switching between the contents of the grid and the effect. So you can see that there's some simple animation techniques demonstrated here. You can go inside and look at all the contents of these, which use various mixture of commands to draw on the control surface. And as I say, this is exactly the same for all of the controllers. This effect here, or this screensaver here, will work exactly the same on the launch pads, on the lemur, on the OMRGB, on the base. So if I look at example 9, then I think we've got various effects here. So I'm just going to turn these on one by one. So that's a pattern that goes around the side. It's just a pattern there. Flashing dots, I missed this one. Similar down there. And a spin there. And another little twizzly thing there. And then I can turn all these on at the same time if I wish and have a nice animation. I can change the refresh rate, which is a bit slow. Send it kind of insane there. And I can also make it clear after every update so we don't get any of the trails, and now we're just getting kind of lots of random lights. And I can turn some of these off if we want. Normal way to do this is just with MIDI clips, but this allows you to do some more complex stuff. There's nothing going on here that's processing key presses, but obviously, you can tie your animations to key presses and locations if you want as well. Okay, so example 10 is another animation. And this time we're going to be drawing some snakes. We have a green snake, and we can change the length of the snake, and we can change the color of the snake. If we want it to be a red snake, change that down there so it's a bit nice. And we can change again the speed, so we've got a nice fast snake. And we can have multiple snakes going in different directions. Just slow that down a bit. And we've got two of the same colour here, so let's just take this one back down to being a green snake. So this is just another example of a simple animation. Again, we can have some nice effects going here. I can get rid of the trails and just have dots. I can change all the offsets where they are in their cycle, and randomize these things, which I haven't done here. So you can generate some nice little effects here, whatever you think of really, and you've got quite a lot of control. So that's what we can do with drawing on the grid in either a destructive or a non-destructive way. As I say, these examples are provided in the downloads, so have a look at them, see how things operate. Have a look at the programmer's reference for more detailed information on the command. And as always, if you run into any problems or you're having any issues, then pop onto the forum at forum.sigabort.co and let me know. Thanks for watching.